Now let's apply the model that we have developed with autoregressive errors to the holdout sample. So here is the holdout sample. I've already set up the time period, month, and the actual unleaded gasoline price per gallon. Now we're going to use this model, so which means that we need L1. Okay, so we need all of these columns to be set up. Okay. Now we have the L1 unleaded L1 crude fitted in error terms for the very first time period, okay, which is the last time period in the estimation sample. So our holdout sample starts from January 2009. Since we need the previous values of these, so let's go ahead and get that. So that's going to be for December 2008. So we have that. Okay. So that's the L1 unleaded. So if we copy that across like that, so we'll have the fitted value, the error, and the U value. So let's make sure that the U value for December 2008, okay, is 49.6324, which is what we have. Okay, so this is our initial value. So let's okay, now let's get these two columns D and E for the holdout sample. So this will be P 170, so P 170. Okay, so then if you copy that over here, we get L1 crude. Now the fitted value, okay, will have to, we can take any one of these fitted formula that we have already set up, and we can copy that over here like that. And of course we want to make sure that the copy works, so we have B12 intercept, B13, so that's B sub 1 times D28 is our L1 unleaded, then B14, which is the B sub 2 times E28, that's L1 crude, and B15 is 5 times H27 is your U. So that's good. So now the error term is actual value minus the fitted value. Okay. We could copy that also from here, and then U, again we can take any one of those U's and copy it here, and again check. So that is equal to 5 times the previous U, okay, H27 plus the error term. So that's good. Now we can copy this rest of the way for the holdout sample. Okay, so and we can then set up the accuracy measure. So if you use the autoregressive error model, so assuming errors are autoregressive, we develop this model, and let's look at how this model works on the holdout sample. So ME is mean error. So mean error, okay, between the actual unleaded prices, comma, the fitted values. The fitted values are our forecast. So that's our mean error, and then we can do MAE. So we have MAE, okay, and then MAPE. And now you see that when we compare this with the previous model that we developed using the forward selection, backward elimination, and stepwise, okay, at that time the best model that we developed, and when we applied that to the holdout sample, we got 19.5% for MAPE, and MAE was 48.92. Now this time is considerably lower. So in spite of the fact that we used a elaborate model selection methodology, the accuracy measures were not that great, and that's probably because we left out these highly correlated variables in the equation, and that's probably the reason why we're not getting very accurate results. Whereas here we are looking at the autocorrelated errors and making sure that the autocorrelated errors are taken into account for the forecasting purposes, so we are doing much better in this case.